All right, so let's get to it. So now we're graphing. We already looked at equations from graphs. So we kind of looked at the equation. We're looking at properties from a graph. Now we're going to look at how we are given an equation and we can build the properties required to graph from the equation. And this is where the 5 key questions comes in, because the 5 key questions are very step-by-step, simple way of taking an equation and pulling the important properties out of it. And this is kind of a tricky process. In particular, one part of it is tricky. So if you can turn it into as much of a step-by-step process as you can, you're going to benefit from that. As I've said previously in the course, if you can build habits and kind of do it in the same order every time, I think you're going to benefit a lot from that. Okay? So what is our goal? Our goal is for the 5 critical points, and I'm just going to do it for sine. So you might imagine those ones look like they're from the base function. That the 5 critical points are what we call lattice points. And I probably talked about this before, but it was back when we did the grade 11 stuff. What is a lattice point? So if you get a point that falls like that, that's no good. Or like this is no good. Or like that is definitely no good. A lattice point is where the grid lines meet. So that's your goal. That's the challenge, is that all 5 of those points, obviously the rest of the function won't, but those 5 points have to be where grid lines meet. And the whole trick to that is when we come up with the scale. Okay, so that's the trickiest part of all of this, is developing a scale. And once you've got the scale and you've got it kind of labeled, if you've done everything right, the graphing's actually really easy. Okay, but coming up with the scale and understanding exactly how it works takes a little bit of time. It's a little messy. All of this is going to be a little messy. It's the kind of thing where you got to get your hands dirty with it. You just got to get in there. You're going to be a little unsure at first. You just have to try it a few times. And I can tell you in my experience, over and over and over again, the first time somebody tries this, they feel unsure about it. But after they've done it 3 or 4 times, all of a sudden they're like, oh, okay, now I'm getting it. Okay? And so you just have to make sure that you get there as well. What are the 5 key questions? Teachers do these in a little bit of a different order, I think. So this is the order that I do them in. The order doesn't really matter. Which question is which doesn't really matter. Again, I would strongly encourage you to do them in the same order every time. And again, I don't know why you would change the order from the way I do it, but do it in the same order every time just so that you have a habit, right? Okay, so I always do the 0 line first, then I get the amplitude, and with the 0 line and the amplitude, we can find the max and the min. Because the max is the 0 line up the amplitude, that takes you to the max, just like this, right? The min is the 0 line down the amplitude, like that, to take you to the minimum point. And look, for sine, 2 of the points, one of them is at the max and one of them is at the min. Well, if you know the max and the min, now you know kind of half of where to put those points. For cosine, you got 2 points at the max and 1 at the min, so same thing, right? That's where that's the vertical place where some of those 5 critical points occur. The other points occur on the 0 line. Well, we've already got that. So now we already know, after those first 2 questions, the y values of where to put all 5 points. So then we got to go figure out the x values. So where does it start? That's like your phase shift, your c value. These all go together with one of the variables, right? In fact, I'm going to write that down. Y equals a sine, just because we drew sine k, x minus c plus d. You need to know that because when we look at the equation, we need to know which one's a and which one's c and which one's k, right? Like we need to know which one's which. And the a, k, c, and the d are what give us all of this. So where does it start? Your phase shift, that's like your c value. What is the period? That comes from the k value. Remember, we were doing that yesterday, but in the other direction, but the k value. And where does it end? Well, we're going to do a little bit of calculating to figure out where it ends. And the end, in the method that I use, again, some teachers do some of this a little bit differently. So the way that I do it, the end is going to be our check that we did it correctly. So when you've done it right, your last point will be where you calculated your end to be, and you can be pretty sure that what you've done is correct, or almost correct. Okay? And after we've done all of that, we got to work out a proper x scale. And that is the tricky part. Our first example is not going to highlight that super well because it's kind of a simple one to get us warmed up. Our second example is where we're going to dig into the difficulties of calculating an x scale. Just to give you a heads up of what's going on. Okay, so let's try one. Whether you are graphing, because you're given the equation, or your task is to come up with the equation similar to what we were doing yesterday, it all boils down to a, k, c, and d. So what I would do if I was starting is I would write them out. A equals k equals c equals and d equals. And again, this takes a problem that feels like a big problem and starts breaking it down into smaller parts. And whenever you're working with an equation, and you're going to see, unfortunately, it won't be until after the week that we're away and come back, but we're going to do the last couple of lessons of the course where it's, again, going to all revolve around A, K, C, and D. And so this is just a good habit. When you're working with the equation, don't think about the equation as a whole. Think about the individual parts to it. So does somebody want to give me one of those? A is 2 over 3. Good. K is 3 over 2. Good. The fact that they're reciprocals is irrelevant. Huh, what are the other two? A little tricky?
0.
Which one?
Both.
Good, yeah, both. So they're both 0, so that's why they're missing. That's why this one's going to be a little bit simpler. The fact that C is 0 is going to make our life a little bit easier. And so the scale, coming up with the scale is not going to be quite as hard. Okay, good. So question 1, zero line. Zero line comes from the, oh yeah, go for it. Huh? Yeah, it's 0. Comes from the D value, right? So we write it as an equation because it is a line, so y equals 0. And that one's done. Question 2, amplitude. What's the amplitude?
4 over 3.
No? Why do you think that?
Oh, I was doubling the amplitude.
You were doubling the A value. The A value is the amplitude, so it's just 2 over 3.
Oh, really?
But you were thinking that because the amplitude, double the amplitude takes you from the max all the way to the min, which is correct. So that would be the distance, 4 over 3, between those 2 points. But we want the amplitude, and it's the same as the A value. So we don't need to do any work there. It's just 2 over 3. Sometimes there's some, as well, just kind of messy fraction math in these questions. This one's not going to be too bad because of the 0 again, but I think we're going to see it in another example, and we'll definitely see it in the practice where sometimes, yep, you're just doing some fraction math. Again, like I've said before, if you have a calculator that can do the fraction math for you, well, and you just want to let it do the heavy lifting, then go for it. Or if you are starting to feel more confident with fractions because of the fraction work we've done with radians, you might be able to do it in your head. So the max is the 0 line plus the amplitude, and the min is the 0 line minus the amplitude. Whoops. So because it's 0, this isn't really what I would call fraction math. That order matters. Listen carefully. Somebody in here right now is not listening to me. Order matters. You have to start with the 0 line. I start with the 0 line in the 5 key questions. Maybe that's a tip. Start with the 0 line here. Start with the 0 line here. You cannot do those in the other order. You can't start with the amplitude. You have to start with the 0 line. And again, to me, this is a visual thing. Don't copy this down. You start on the 0 line and go up to the max. You start on the 0 line and go down to the min. Like it's a visual thing. So I'm starting from the 0 line and going up the max and down the min. Does that make sense? To get those max and min points. And that part's done. And we have all our y values. We know where all the points are going vertically. Start. It's your phase shift. That's your C value. So in this case, it's just 0. Period. So this is that little formula. It's not 3 over 2 though, but it's related to 3 over 2, correct? It's 2 pi divided by the k value. So I think we had this written down on a different handout, but write it down here in the first lesson. I don't usually write out the formula with the k in it. I just go 2 pi over 3 over 2. Again, there's some fraction math here. So if it finally clicks for you, this is a one-step question, and it works out to 4 pi over 3. If that looks like magic still to you, calculator, or you do it the long way, which is 2 pi over 1 divided by 3 over 2, which is 2 pi over 1 times 2 over 3. 2 times 2 is 4. 1 times 3 is 3. 4 pi over 3. So if you do enough of these, you just take the denominator, multiply it by that numerator number, and leave the 3 on the bottom on its own. So the end is the start plus the period. Period is the length of one full cycle, so it makes sense that if you start at the start and you add the period, you get to the end. So again, there could be some fraction math here, but in this case, the 0 makes it easy. So our end is just 4 pi over 3. There's another method of graphing that some teachers use where they plot the start and the end and then work their way in from there. I don't do it that way. I start at the start and plot each point in succession. And when I get to the end, I can see that it's correct, end. But both ways work pretty much the same. So if you're struggling with something, we could talk about adjusting slightly and see if there's a method that works a little bit better for you. Ready? Here comes the hard part. Again, not super hard for this example, but this is the hard part. I think most of that should be straightforward. Fraction math, yes, can be tricky, but I think lots of people can use their calculators or, like I say, are starting to get good at this. So here's how I do it. I calculate this thing called the critical point distance, the distance between critical points. The critical points are those 5 critical points that we have to plot. I want to calculate the distance between them. So how do I do that? You take your period and divide it by 4. Why 4? Because when I divide the entire period by 4, there's 5 points, but the first one doesn't really count, because that's where you're starting. So we go 1 distance, 2 distance, 3 distance, 4 distance to get to the end. So I'm dividing the entire period, 1 full cycle length, into 4 quarters, and those are going to be your 4 other points. So it's always 4, and you just memorize that it's 4. So in this case, it's 4 pi by 3 divided by 4, which works out to pi by 3. And I do this in a very specific way, so I would recommend you kind of set it up the same way if you're gonna do it like this, where I do the critical point distance and then I put the phase shift right under it, so that I've got them one on top of the other like that. It's just a notational. This is just organizing the data. This is not going to be, as I've said all along, this is not going to be the best example, but I'm going to explain what's happening here. Now I have to pick some value that's going to work for both the critical point distance and the phase shift. Why do we have to do that? Well, if my phase shift is 45 and my critical point distance is 30, and I decide to count by 30s, 45 isn't on that scale. 30, 60, 90, 120, there's no 45. Right? So if I had a critical point distance of 30 and a start of 45, what number would you pick that would work for both? 15. That's so easy to do when you're working with degrees, right? Because we've done so much of that kind of math. But when you're looking at it like pi by 6 and a pi by 4, it's not as obvious. You could do the conversion. You could convert them to degrees. I've said that you're not supposed to be doing that, but do it in your head. Think of it that way. I mean, I wouldn't know you're doing that, so that would be a strategy. Because the phase shift is 0, we're not really going to see what's happening in this case. But that's the trick, okay? And the other trick is, if the distance between points is 30, and we chose to count by 15, every 2 squares would be a point, right? 15, 30, 45, 60, right? And you're counting actually 30 degrees between points. So this is the other thing that we're calculating, is how many squares are going to be between points. So what you do is you get a common denominator between these two things. Because this is 0, my common denominator is just pi by 3. And you just write that down. And now you decide how many squares do you want pi by 3 to be. Don't write this down. If I made pi by 3 equal to 1 square, this would be my graph. Like, that's ridiculous. Right? It might actually be more like this, but I mean, come on. This is not appropriate. So we got to stretch it out and use more of the grid. Okay? So pi by 3 is the distance between points. So I'm just going to make that equal to 4 squares. And therefore, there will be 4 squares between critical points. Now we draw our graph, label it with the scale and everything we need to label it with. And once we do that, the actual graphing part, if we've done our job correctly, is going to be really easy. Okay. Again, for this one, it's not going to be super obvious, but I'm going to talk about this every time because it does become important. you will have a good sized grid on the test, but it won't be like super huge. So don't copy anything down yet. This is what some people like to do. Where's the middle? Right around there. Like that. And then like that. So this is very wrong. We don't just put our axes in the middle of the grid. That's what you did in grade 9. When we're graphing trig, it doesn't make any sense. We're starting at 0. Okay? So that means this entire part of this grid is going to be unused. If I'm counting 4 squares between critical points, and I've got 4 of them, 16 squares, if I don't make sure I have 16 squares over there, my point's going to go off the grid. And that's your other job, is you need to make sure all 5 points are on this grid, both vertically and horizontally. Okay? So you have to think just a little. It's not going to be hard, but you have to put some thought into it, where to put your axes. So I'm going to put the vertical axis over here, not at the very, very edge of the grid, because we've got lots of space for this question, but kind of way closer to this side. And because there is no shift up or down, I'm going to put my x-axis in about the middle. I'm going to do the vertical axis first. We're counting by thirds to get to our max and min. Once again, do I want a third to be 1 square or 2 squares? So just watch. If I do 1/3, 2/3, 3/3, I'll go from here to here, something like that. And that's fine. Or let's see if I can, hold on. 1/3, 2/3, 3/3. So I'm making a third 2 squares, and that'll stretch my graph out a little bit more. 1/3, 2/3, 3/3. So that's -1. That's +1. So I'm going to do that. It would have been fine to do it the other way as well. If you can stretch it out a bit, that's a good idea. It can't be too small. There's a couple of graphs in the practice that you don't have a lot of choice just by the nature of how they are. For example, if you have a really long phase shift to the right and you have to start way over here, I mean, no matter what, you're going to kind of be running out of grid space. So you got to be careful, right? But if you have a shift to the left, then that's usually way safer because you can just put your first point way over here, and then you've got the entire grid to play with, and you can stretch it out. Okay, pi/3 was every 4 squares. So I'm going to count 4 squares, 1, 2, 3, 4, and put pi/3. 1, 2, 3, 4 to 2 pi/3. 1, 2, 3, 4 to 3 pi/3, which is pi. And yes, you have to reduce those fractions when you're labeling your scale. Oh, I got to keep going. Sorry, 1, 2, 3, 4, 4 pi/3. 1, 2, 3, 4, 5 pi/3. 1, 2, 3, 4, 6 pi/3, which is 2 pi. Again, my rule is your scale has to be labeled past your last point, or at least up to your last point. Our last point is at 4 pi/3, so we're good. And if we've done our job correctly and we've chosen the right scale, everything should just work. Remember, if you choose the wrong scale, you're going to end up with either your first point doesn't fall as a lattice point, or your next point won't fall as a lattice point. Okay? Or if you made your scale, if you stretched it too much, your last point is going to go off the grid, and then you got to go back to the start and redo it and figure out a new scale that's going to work better. All right, I just want to check and make sure we've got everything done before and said before we want to move on. Okay, let's do it. So this is what I do now. We've got everything written down that we need. Our first point, this is what I always do after I've got all that done. I go back and I make sure I'm going to graph the right thing, because believe it or not, you'll be asked to graph cos on a test and you'll graph sine by accident for whatever reason. It's got sine on the brain. So I go and double check which one I'm actually graphing before I do it. And I also check for reflection. We didn't talk about the reflection. You could write it down. I think some people like to. There's no reflection in this case. You could write down that there is a reflection. I often don't do that just because I always go back and check. But that's up to you. But it is one thing that I check before I graph. Okay, so no reflection. We're graphing sine. Sine starts on the 0 line. We're obviously starting at the start. So this one starts at 0, 0. You could draw the 0 line in. Some people like to do that. Do it like faint with pencil or a dotted line. Okay, don't make it too dark. Don't make it look like it's the x-axis. That's all I would say. Now this next part's not hard, but it's maybe a little bit different. Remember we calculated that there are 4 squares between critical points? Sine is not reflected, so the next point is the max. So I count 1, 2, 3, 4, and I go to the max. 1, 2, 3, 4, back to the 0 line. To the minimum, 1, 2, 3, 4, back to the 0 line, 1, 2, 3, 4. And I've got my 5 critical points. And look at that, the last one ended at 4 pi by 3, just like it was supposed to. So we're good. Now we have to draw it. This is not how you draw sine, folks. Oh my goodness. So smooth curve. Don't go past the points and put an arrow or anything weird like that. We're only graphing one cycle. We stop at the start and the end. Any questions? This graph worked out such that every point was at a label on the x scale. That's a fluke. That won't usually happen. That's not my expectation. Okay? So we are labeling the scale however we want to label it. Every 3, 4, probably I would say every 2, 3, or 4 squares, you should be putting a tick mark with a label of what it is. So that may or may not align with where the critical points fall. If I shifted all of this back 1, they would all be 1 back from a label on the scale, and that's fine. Some people expect this to happen. It doesn't always happen. It's not going to happen in the next example, and it makes for a little bit of extra work in some situations, but that's just life. If we're doing pi by 3 is 4 squares, what's 1 square? Pi by 12. Divide pi by 3 into 4. So pi by 3 divided by 4 is 3 times 4 is 12. So pi by 12. So 1 pi by 12, 2 pi by 12, which is pi by 6. 3 pi by 12, 4 pi by 12, which is pi by 3. 5 pi by 12, 6 pi by 12, which is pi by 2. 1, 2, 3, 4, 5, 6 to get to pi by 2. 1, 2, 3, 4, 5, 6 to get to pi. Right? I could have chosen to label more points on this grid. You don't have to. Every 4 and labeling by pi by 3 in this situation is worked out fine. But there is going to be some choice in how you do these things. Any questions? Okay, ready to try a slightly harder one. Anybody notice something that's a little off about this one?
The K is like multiplied into the C value.
Yeah, so this is not okay. This doesn't happen very much, so don't worry too much about it. Well, I shouldn't say don't worry too much about it. I mean, it could come up on a test. I don't think there's any in the homework, but it is something I think you talk about in grade 11. It is something we need to be aware of, that when we are doing these, it does have to be in the right form. So we have to factor that out. So I'm just dividing it. And I had to divide it out of the 3 pi by 4 to get, like, 3 pi by 4 is divided by 3 is 1 pi by 4, right? Plus 1. So just, watch for that. Something to be aware of. Now we're going to write out A, K, C, and D. Who can give me one of them? D is 1. Here's our 0 line. A is 2. What kind of 2? So I think you were thinking, maybe you were thinking amplitude is always positive, so that's good. We'll come back to that. But the A value includes the negative, okay? So A will be negative 2, but you're right when we get to the amplitude. One of the last two?
K is 3.
K is 3. And C? Good, negative pi by 4. And so if we didn't factor the 3 out, you probably still would have said K was 3, but you would have had the wrong phase shift. Right? So your graph would have been, like, you could still graph it. So you'd still get full marks for graphing. You would have missed 1 mark on a test for missing that you had to factor it out, but it wouldn't be the end of the world. Okay, but you'd get the wrong C value. All right, 5 key questions. First one is the 0 line. So the 0 line, I already said this comes from the D value, so it's y equals 1. I'm going to go through these a little bit more quickly because hopefully this is the easy part, and I want to spend our time on the scale. Question 2, and I want to get to the point where you can try some of these because I think that's what's going to be important. Amplitude. So we got ahead of ourselves a little bit, but the amplitude is not negative 2. It's always positive. If you said it was negative 2, you're really going to get mixed up with your max and your min because your max is going to be below your min, and it's not going to make any sense. Okay? So amplitude has to be positive. And now I calculate my max. It's the 0 line plus the amplitude. Remember, order counts here. You have to have the 0 line first and add the amplitude. And for the min, start with the 0 line and subtract the amplitude. And there is a reflection. Okay, question 3, start. Adding pi by 4, means a shift to the left. So our C value is negative, and our start is negative pi by 4. If you're talking about transformations, it's opposite of what's in the brackets, but it's the same as the C value. Generally speaking, I'm not marking that you've written the correct C value. So if you wrote C equals pi by 4 and then said your start was negative pi by 4, I mean, there is a mistake in there. You might lose half a mark, but that's not a lot. Generally, that's not really what I'm marking, right? I'm marking that your graph is right and your properties are right. 4 is the period, which again is 2 pi divided by the K value. As I said before, sometimes there's a little bit of fraction work to do in there. Not this time, it's just 2 pi over 3. There's nothing to do, right? And 5, is the end, which is the start plus the period. So this one's a bit trickier. So again, you could use your calculator to do this, or you could realize that this is negative 3 pi by 12 plus 8 pi by 12, which is 5 pi by 12. Any questions about that? Okay, here comes the tricky part. Who remembers how to calculate the critical point distance? Period divided by 4. Or you could think of it as times 1 over 4 if you want to go straight to the fraction math. Like, I don't care, that'd be fine too. So it's 2 pi over 12, which is pi over 6. That has to be reduced. In fact, I'm going to show that because I've seen people leave it at 2 pi by 12, so I just want to point that out. Has to be reduced to pi over 6. Technically, you could get away with it, but trust me, you want to reduce it to pi over 6. Then I bring in my phase shift, and notice how I write them one on top of the other. And my phase shift, the fact that it's negative doesn't matter. But just to be consistent and precise, I'm including it. Now, because we have two fractions with different denominators, it's a little bit trickier. The example I used before was 30 and 45, and that's the same thing that we have here. So like we did the thinking in degrees before, and if you have to, then do it that way. But here's the way you can do it with fractions. It's actually pretty easy once it clicks for you. What is a common denominator between pi by 6 and pi by 4? Huh? Pi by 12. So you just find that common denominator as if you were adding them together and write it down. Here's a little tip. A lot of the time it's pi by 12. Okay? So 6 times 2 is 12. 4 times 3 is 12. They both multiply to 12, so 12 is the common denominator. In this case, I could just go with pi by 12 equals 1 square. Why is pi by 12, why would that work? Or what would happen if I made pi by 12 1 square? Well, here, now I'm ignoring this, by the way. Okay, for now. It'll come into play when we graph, obviously, but right now I'm looking at those two only. And 6 times what gives me 12? 2. What this means is, if I made pi by 12 equal to 1 square, I would have 2 squares between critical points. Because 6 times 2 is 12. And if you don't like that, pi by 12 is 15 degrees. Pi by 6 is 30. So 15, 30, right? Like you got to count 2 squares. But this is the relationship. The fact that I multiplied the 6 by 2 to get the 12 means it's 2 squares between points. So what if I make pi by 12 equal to 2 squares? Then how many squares would be between critical points? 4. What if I made pi by 12 3 squares? How many squares would be between critical points? Yeah, Saj? Yeah, 6. I don't usually write this down. I just do it in my head and pick one. And then I write that one down. So I'm just going to go back over this. This is a little bit tricky. This is the part right here where I say when you go to practice this on your own, you just got to do it. You just got to try, and then I'll come around and help and talk you through it. And once you've done it a few times, it's one of those things that should click. You get your critical point distance and your phase shift. You find a common denominator between them. If you have to multiply to get the denominator to equal, that's how many squares would be between points. Then you decide how many squares. Like you're just choosing. Do I make pi by 12 one square, or 2 squares, or 3 squares? And that will just depend on how stretched out your graph is. Because if I do 6 squares between critical points, my graph is going to be stretched more, right? Can you visualize that? And if I only do 2 squares, it's going to be very small. 1 square is not allowed. You will be docked marks on a test for choosing a bad scale. 2 squares is okay only really if you have to. So you should try to stretch it out more than 2 squares. An example of this would be, like I said before, what if I put my y-axis there and I had a phase shift that started like halfway through the scale, and going by more than 2 squares would take me off the graph? In that case, and there's one in the practice that's kind of like that, I think. So in that case, it's fine. But if you can go more than 2 squares, that's better. So 4 or 6, I think, in this case would both work. My phase shift is to the left. So I can put that point as far to the left as I want if I put my y-axis in the right spot. Okay. I'm going to go with pi by 12 is equal to 2 squares. And so it'll be 4 squares between critical points. I'm going to go with that one. And it's because the multiplier between the 6 and the 12 times 2 gives me 4, right? So 4 squares. Okay, let's see. We've got a shift up by just a little. So I probably want to keep my x-axis a little bit lower. And when you go to put your axis, like don't just draw it randomly. I think you think about this. You might already start thinking about how you want to do your vertical scale. We have to be able to get down to -1 and up to +3. So if I start here and count by 2s, 1, 2, 3, like I've got lots of space to get both those points in there. But notice I didn't put it right in the middle. I put it down a bit because the 0 line is shifted up. And then same thing with this. And in fact, honestly, what I do sometimes, with just 4 squares between points, it's not that big a deal. But I might say to myself, what if I put it here? 1 pi by 12, 2 pi by 12, or sorry, that's 2 squares. 1 pi by 12, 2 pi by 12. Oh, look at that. 3 pi by 12 goes off. 3 pi by 12 is pi by 4. That's our start. So this would be a bad place to put it. So I'll go over 2 more. I'm going to show you again what I mean by this. So let's see. If you want to do it exactly like me, I went 1, 2, 3, 4, 5, 6, 7 squares in from the left. Okay, just watch. Up here, we found pi by 12 was a common denominator. We chose to make that equal to 2 squares. So when I go to mark this, I'm going to go 1 pi by 12, 2 pi by 12, which is pi by 6, 3 pi by 12, which is pi by 4, negative pi by 6. I'm not marking that because I want my scale to be marked consistently, not just like with random numbers all over it. Pi by 4 is the start, so there's going to be my start. So see how I managed to put it very close to the left of the grid. Okay, now we'll go the other way. 1 pi by 12, 2 pi by 12, which is pi by 6. Now that I know that 4 squares is pi by 6, I could start counting in pi by 6s every 4 squares. You know what I mean? That's up to you. 3 pi by 12, 4 pi by 12, which is pi by 3, 5 pi by 12, 6 pi by 12, which is pi by 2, 7 pi by 12, 8 pi by 12, which is 2 pi by 3, 9 pi by 12, 10 pi by 12, which is 5 pi by 6, 11 pi by 12, oh look at that, 12 pi by 12, which is pi at the very end. We're not even going close to pi. We're not even going to pi by 2, so we've got lots of space. I already kind of said I was going to go every 2. Any questions so far? Folks, it is a lot of counting by squares. Is it a lot of converting fractions as you're counting and reducing fractions? It's a lot of nitpicky thinking about what 1 square equals or 2 square equals and what does that mean about the distance between, you just can't avoid that. If you want there to be a better way, I'm sorry, there isn't. Okay? But again, like I said before, trust me that when you start doing this on your own, you might find it's a little bit easier than you think. All right. I think we're ready to go. Everything's labeled. We're doing cosine. Cosine starts at the max, but we have a reflection. So we're going to start at the min. And we're obviously going to start at our start. So negative pi by 4, negative 1. So I already figured out where negative pi by 4 is, but if you hadn't, how are you going to... Pi by 4 is not on our scale. This is what... Well, you just have to go back and figure it out. 1 pi by 12, 2 pi by 12, 3 pi by 12 is pi by 4. Therefore, I'm going to 3 pi by 12s at negative 1. And there's our start. We calculated 4 squares between points. So I go 1, 2, 3, 4 to the 0 line. 1, 2, 3, 4 to the max, which is 3. 1, 2, 3, 4 back to the 0 line. 1, 2, 3, 4 to the min. All my little tick marks are pi by 12s. Because I labeled every 2, but I was ticking at every pi by 12. Just everybody watch, right? 1 pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12, 5 pi by 12, our end. So looks like everything worked out. Any questions? All right, here's what I'm going to say. I want you to try this one. Okay? And we'll see how far you can get to the scale and give it a try. And then we'll take it up quickly. so this is what you should have for the properties. If you haven't got them all yet, maybe don't cheat and keep trying to get them yourself. Oh. How many people have already tried to get the period or the critical point distance and the scale? Okay, lots of people. Not everybody, and that's okay. I think we kind of need to move on because we do have other stuff we have to do, obviously. So this is what I've started with. Your critical point distance is your period. Be careful. Some people by accident take the end just because it looks like it could be the period. Okay, so be careful of that. We need the period, divide by 4. So that's just pi by 4. Compare that to our phase shift, which is our start. So that's pi by 3. And I get the same common denominator of pi by 12. But in this case, it's different because 4 times 3 is 12. So there's already 3 squares between points. If I made pi by 12 equal to 1 square, I would have already 3 squares between points. Remember, pi by 12 is 15. Pi by 4 is 45. So if I'm counting by 15s and I need to go 45, I need to go 3 of those. The phase shift is 60. Again, I need to pick a scale that I'm counting by that has 60 on it, because that's where we're starting. So if I was counting by 45s, 60 is not on that. 45, 90, 135, there's no 60. You can't do that. Right? So I have to count by something that is common between 45 and 60 in this case. So, the obvious one is 15, and that would work. I think I'm going to double it, and I'm going to say pi by 12 is equal to 2 squares. Therefore, there will be 6 squares between critical points. I want to explain this again because this is the part that people have a hard time understanding. I'm going to use this grid. Imagine that this is my first point. So there's already 3 squares between points because 4 times 3 is 12. That's the relationship. Right? So if I was 1 square, I'd have to go 3. If I make it 2 squares, I have to go 3 twice. Right? It would be like going 1, 2, 3. Because every 2 squares is pi by 12, as opposed to every 1 square, 1, 2, 3. It's a little weird because now 1 square is 7.5. And that's an odd thing to count by. But because we're working in fractions, it really doesn't matter. We don't even really care what 1 square is. I'm going to make pi by 12 2 squares, and I'm just going to count by pi by 12s every 2 squares. I'm not going to count every 1 square. It'd be pi by 24. Again, that's 7.5 degrees. It's a weird scale. You would never do that in degrees. You would just go with 15 or maybe 5. But that would make your graph probably too big. Okay, so not too worried about what it actually is. I'm just going to count by pi by 12s. If you said pi by 12 was 1 square and you went 3 squares between every point, that would be fine. Okay? The other thing, folks, that you can do, like I think this part you can do, but if it's figuring out the squares, you're not too sure, just guess and check. Do it in pencil and erase and do it again. If it doesn't work, like just say every 2 squares and try. Oh, no, went off the graph. Okay, I'll go back to every 1 square. You know what I mean? Like just try it and see what happens. Okay, so let's get this done quickly. Our shift, our phase shift is to the right. So I'm going to start way over here. I'll move in a few, but actually I'm going to go way over to the side. And our shift is down again. So I'll put this up just a little bit. Now I have to count my y scale by thirds. If I do a third every 2, let's see if I'll fit on here. 1, 2, 3, 4. Yep, I will. So I think I'm going to do that. So 1/3, 2/3, 3/3, which is 1 and 4/3. And 1/3, 2/3, 3/3, which is 1. Sorry, that should be -1. Counting by pi by 12s every 2 squares. 1 pi by 12, 2 pi by 12, which is pi by 6. 3 pi by 12, 4 pi by 12, which is pi by 3. 5 pi by 12, 6 pi by 12, pi by 2. 7 pi by 12, 8 pi by 12, 2 pi by 3. 9 pi by 12, 10 pi by 12, 5 pi by 6. 11 pi by 12, 12 pi by 12, which is pi. 13 pi by 12, 14 pi by 12, which is 7 pi by 6. We have a problem. I should have counted better. This is exactly the kind of thing that's going to happen, though. What happened? So look at this is, if I'm going 6 squares 4 times, I need 24 squares. I'm actually surprised this isn't 24 squares, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. How many? Oh, but we're starting at pi by 3, so we need them from there. 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're 2 squares off. So what do we have to do? We talked about this before. Yeah, we're going to have to go back and make it 1 square. And just do 3 squares between critical points. So again, that was because of the phase shift. The phase shift was not huge, but it was enough to the side that even putting my y-axis all the way to the back wasn't enough. So this is the kind of thing that happens. So 1 pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12. That's not what I want to do, sorry. 1, 2, this is pi by 6. Pi by 3. it was 14, 15, 16 pi by 12. There's your 4 pi by 3. Pi by 12, which is 3 pi by 2. And I can stop there. Okay, let's quickly graph this. It's sine. Sine starts on the 0 line. No reflection. 0 line is -1. Start is pi by 3. So -1 and pi by 3. I'm going up and down a third, and I made a third 2 squares. So we're counting 3 squares over 1, 2, 3, up. 1, 2, 3, back to the 0 line. 1, 2, 3, down to the minimum. Back to the 0 line, 1, 2, 3. The end is 4 pi by 3. That's what we were hoping for, so now it worked.